Hi, everybody. Welcome to today's Cathedral webinar. We are coming to you live on January 20th, 2026. You are tuning in today for Heat Pump 101, Efficient Heating and Cooling for Tribal Homes and Facilities, with your instructors, Mike Stevenson and Stephanie Bostwick. My name is Brooke Warrington. I'm the Training and Development Specialist here at the Native Learning Center. Thanks so much for tuning in for today's webinar. If you could follow along while I read the disclaimer aloud, this webinar provides a summary of fundamental concepts, requirements, and/or procedures within the allotted 90 minutes. The material discussed does not illustrate all possible scenarios that could be applicable. This is just a friendly reminder. Our webinar materials are protected by copyright, trademark, trade secret, and other intellectual property laws. And moving forward, if you need to revisit this webinar, you can find the slides, the recording once it generates tomorrow, as well as many other helpful courses there in the courses section on the webinar. I did put a link to the presentation slides for you in the chat also. And then if you opt to tune in for a webinar in the future, you'll just log in like you did today and click on that green banner at the top of the screen. We do ask that you join with listen-only capabilities because we are recording the webinar, and it just helps to cut down on audio feedback. If you did join, though, and your sound is coming out of the wrong device, you could go down to the bottom of your screen where I have a telephone icon. You probably just have a headset icon. But either way, that is going to bring up a list of your speaker devices, and you can select the proper audio output. And even though we ask you to join on mute, we do still welcome class participation. We want to hear your questions. We want to hear your comments. Certainly any tech support issues that I can help you navigate through. And we are primarily going to rely on the public chat for that. If you don't yet have it open, you could go to the messages column. It's gray to the left-hand side of your screen. If you click on public chat, it will open up the chat between the instructors, yourself, and NLC staff. So you can just come down here to send message to public chat, type in what you want to say or ask, and then hit enter. Or you can select the little paper airplane and that'll send it in. Another important thing to check out is the shared notes section. We have a lot of important links for you in there. Once again, you can find the presentation slide link, as well as the webinar feedback survey, a link to friend us on LinkedIn, our YouTube channel. There's all kinds of good stuff in there. And then if you think we missed a question or comment along the way, you are absolutely welcome to use the hand raise feature to draw our attention to the chat. We'd love if you got it going for us before we get started by introducing yourselves in the chat. You could let us know your name, where you're tuning in from, your work or your role in Indian country, and your tribal affiliation. You might be a tribal employee and you don't have your own affiliation. That is okay too. You are still welcome. And then just a quick final note while you guys are introducing yourselves in the chat. You want to avoid clicking on that menu panel that's red all the way to the left-hand side of the screen, just because it will pull you out of the webinar immediately and take you to whatever you clicked on. But if you do, no worries. You can always just rejoin by clicking on that green banner. All right, y'all, while you're introducing yourselves, it is with great pleasure that I introduce your webinar instructors, Mike Stevenson and Stephanie Bostwick. And Stephanie, I have made you presenter now.
Awesome. Thanks, Brooke. Hi, everyone. Oki Nixugoax, Nistu Netaniku Ikutsianiaki, Nimtutuam Skapipigani. Hello, friends and relatives. My Indian name is Red Shawl Woman. My English name is Stephanie Bostwick, and I'm Blackfeet. I'm a former aerospace engineer and spent several years working on satellite systems before I got into higher education. And I actually started an engineering program at Northwest Indian College here in Bellingham, Washington, focused on renewable energy and energy sovereignty for tribes. And in doing that program, did a lot of workforce development with Lummi Nation, including energy audits, solar installations, microgrid feasibility studies. So did quite a bit of work in workforce development and ended up eventually at the Office of Indian Energy, which is under the Department of Energy, as the Tribal Colleges and Universities Coordinator. That's where my colleague here, Mike, and I worked together, doing a lot of piloting of these training and workforce activities with tribal colleges and universities. And last year, we both left the government and started our own consulting companies, basically doing similar work. So our goal is to build capacity in Indian country so that you all have the tools to make your decisions and do the work yourselves so that you can move toward energy sovereignty. With that, I'll pass it off to my colleague, Mike.
Thanks, Steph. Good afternoon, everybody, or good morning if any of our friends are on the West Coast or Alaska. My name is Mike Stevenson. I'm an electrical engineer, and I have a really good fortune of working with tribes across the lower 48 and Alaska to pursue their visions for energy development. A dozen or so years. I founded Resilient Energy Solutions not quite a year ago when Steph and I left the federal government. With the feds, I oversaw the technical assistance the Department of Energy, Office of Indian Energy provided to tribes nationwide for close to 6 years. And prior to joining the Department of Energy, I was with the Small Tribal Energy Office in the Department of the Interior, the Division of Energy and Mineral Development. I spent 6 years primarily helping tribes through grants and technical assistance explore microgrid feasibility and tribal utility formation feasibility activities. This is the last of a 4-part webinar series on energy-related capacity building, the last of this initial round, I guess I should say, and incredibly fortunate to have the opportunity to partner with the Seminole Native Learning Center. Georgette and Brooke, as you all probably know, are absolutely wonderful and delightful, and we really appreciate this opportunity to bring you this material. We hope you find it a good use of your time and informational. And if you've been with us on the previous 3 webinars, today is the same. Steph and I, we're usually doing this in person, and we can kind of read your face for feedback and understanding, and it's a little bit more difficult in this environment. We ask that you please don't hesitate to interrupt us. We would much rather have a discussion around any of these slides in real time. The opportunities for questions at the end of the sections and at the end of the presentation. But if you have something pop up, please drop it in the chat, and we'd be happy to get more of a discussion going on these slides. And so thank you again. Appreciate you attending today. I know you're all very busy, and look forward to getting into heat pumps with you. So we've got a few things on the agenda today. We're going to go through what is a heat pump, what are they, how do they work, how to size and locate a heat pump installation, and the associated workforce opportunities, and then some operation and maintenance as well. So with the heat pumps, we really think this is going to be a great opportunity in the next few years to get this technology deployed on a larger scale in tribal housing. Seemingly the federal government doesn't seem to, the indicators are that they're not really going to support renewable energy projects through the Department of Energy, Office of Indian Energy anyways. I think some of that's still up in the air, but we do have strong signals from their staff that they're really going to support air source heat pumps going into homes. And we'll get through some of the benefits of that, and also, you know, some of the long-term workforce development opportunities associated. This is not data centers. This is not large-scale solar. It's not going to make anybody rich, but what it will do is make a significant impact on your members' monthly energy bill and keep a handful of people working long-term. You know, this isn't a solar training where you've got a prevailing wage job for a couple of weeks and then no work. I think any of us that have spent time in Indian country realize the need with tribal housing across the country, and these things really do work pretty well everywhere, and excited to get into it in greater detail with you here. So energy efficiency, we wouldn't be doing our jobs well if we didn't advocate for energy efficiency measures as a first step. Oftentimes, and we've seen it a lot in the past, the government has funding for new solar or wind or even the heat pumps we're going to be talking about today. And we put these new energy projects on very leaky homes. But the absolute cheapest kilowatt hour is the one we don't use. And there's a lot of efficiency work needed in tribal housing, particularly in the non-housing authority homes. And these measures can really make a huge impact on members' monthly bills with very low cost remedies for solutions. Next slide, please, Steph. And so you may have seen this if you had attended our previous webinars, but in case you hadn't, I wanted to include it. Energy efficiency and weatherization. So one of many reasons we think heat pumps are such a great opportunity for tribal housing is they're incredibly efficient, and they impact the by far biggest usage of energy in the home, which is air conditioning. Now, you might think of hot summer days when you hear air conditioning, but for weatherization and energy auditing purposes, heating is air conditioning as well. And so we're conditioning the air to make it both warmer and cooler depending on the outside temperature. And as you can see by this pie chart, in most homes, heating and cooling use about 2/3 of the annual energy consumed by the home. Next slide, please, Steph. Okay, so that brings us into heat pumps. We'll go into what a heat pump is next, but first I want to point out the graphic on this slide. This graphic shows a fairly typical installation of an air source heat pump, also known as a ductless mini split. We'll talk a lot today about the outdoor unit, the indoor unit, and the run between the two, and how considerations that are key when planning for where each of these components will go on the inside and the outside of the home. Next slide, please, Steph. But before we get into that, what even is a heat pump? Heat pumps are almost always powered by electricity, and the heat pumps we'll be discussing today can both heat and cool a home or building. They are significantly more efficient than traditional air conditioners or heating systems. The picture on this slide shows a heat pump outdoor unit on the right with a traditional air conditioning unit on the left. Typically, a heat pump will use the same energy to run for 24 hours that a traditional air conditioning unit will consume in just 3 or 4 hours. And so they're significantly more efficient. And, you know, to get into, we're not going to spend a ton of time on the science of it, but heat pumps work by removing heat from the outside air to heat a home, or removing heat from the inside air to cool a home. It works the exact same way a refrigerator does. And we'll get into this in a bit greater detail later, but these systems have reversing valves that allow the refrigerant to flow in either direction, which is what allows us to provide both heating and cooling. Next slide, Steph. So there are multiple types of heat pumps. You know, we're going to cover air source in greater detail because we think that that is the real opportunity for workforce development. But we also wanted to cover and talk through ground source heat pumps as well. Excuse me. So ground source systems take advantage of the fact that about 10 feet below the surface of the earth, almost everywhere on the planet, it's pretty consistent 55 to 60 degree Fahrenheit temperature. And in these applications, you know, typically between a 2 and 6 inch pipe is laid out as seen in the picture, and it typically circulates water in cold climates. It will have some antifreeze solution mixed in, and it uses the earth to cool the temperature to 60 or heat to 60, depending on what the environmental conditions are at the time. This technology tends to work the best in environments that get either much colder than 60 or much hotter than 60 degrees. Next slide, please, Steph. And so there's multiple configurations of ground source heat pumps. They can be used with the horizontal loop that was shown in the previous picture, where there's a long stretch about 10 feet deep, all horizontally bored out for the piping, or sometimes vertical boreholes are used, or frequently a combination of both as seen in this picture. It really depends on the size of the building you're trying to heat or cool with the system. These systems can be pretty pricey to install. One of the potential beneficial component of that, however, is, you know, some tribes have the equipment and the staff and can do the trenching themselves. So that money stays local. And, you know, there's often, especially if you're going to do the vertical borehole, fairly significant geotech work. And, you know, again, these are typically used for larger commercial buildings. But when they're built, aside from the cost to trench and, you know, to bury the piping, they can be quite efficient, you know, as long as they're designed correctly for the application and you have that piping in the ground to properly heat and cool the facility. They're pretty low energy. You're basically, your main energy draw is the pump to circulate the water through that piping. But because the network of piping can be so extensive, you know, it's much easier to install a system like this pre-construction for a new build versus retrofitting on an existing building. And, you know, again, the most efficient applications are in places where it gets significantly colder than 60 degrees Fahrenheit in the winter or significantly hotter than 60 degrees Fahrenheit in the summertime. Thanks, Steph. Okay. Any questions on ground source before we move on? I'll make sure I'm keeping an eye on the chat. If, again, please, as questions come to you, don't hesitate to type them in the chat, and we'll do our best to catch it and go through them real time. But now we'll dive into air source heat pumps. So these units extract heat from the air, and it doesn't. They're typically, that's why we want to be 10 feet down. So 10 feet down every season. Now there's going to be some applications in Alaska where you've got permafrost and things to deal with that it's not going to be very viable. But in most of the lower 48, you know, I think in places, Florida may also have some difficulties with a high water table and things of that nature. But most places where you have solid earth 10 feet down, it's going to be a very steady 60 degrees Fahrenheit all around the planet. So that's the benefit, and that's the cost. That's why we have to go at least 10 feet down to get to that stable temperature that the environmental conditions don't really impact at all. Good question. Thank you for bringing that up. And so now as we get into the air source heat pumps, these units extract heat from the air, and the chemistry has really gotten so good that these can operate in very low temperatures and still heat a home quite comfortably. I think when the technology, this is not a new technology, but the refrigerants are a bit newer and they operate in significantly lower temperatures. You know, I don't know if we have on the call my friend Ingemar Mathiasen from Northwest Arctic Borough, but him and Sonny Adams have really pushed this heat pump technology up north of the Arctic Circle in Alaska in the NANA region, and they're working to install 850 units in tribal communities up there, and have reported them working to about minus 35 Fahrenheit. The refrigerant has such a low boiling point that even 35 Fahrenheit can extract heat from the outside air and make the refrigerant boil. And then we take advantage of the energy created during that process of the liquid turning to gas and back into a liquid to heat the home. And so these units really work well in all temperatures, except for the absolute exceptionally bitter cold temperatures. You know, there's times when my Alaska friends will still have to use their #2 fuel gas stoves. But this saves them lots of money because fuel is expensive in that part of the world, and is an additional side effect. These units don't output any noxious gases like legacy fuel appliances do, and help provide better indoor air quality for the homeowner. And I know it's kind of a lot on this slide, but the last thing on this slide is please take note of the picture. We'll discuss this a bit later on, but it can be really, you know, to our advantage to mount these units higher on the wall, particularly in areas that get snow that can drift against the unit. Next slide, please, Steph. So there's also multiple types of air source heat pumps. They can be ducted or ductless systems. We're going to cover that as well when we go through the installation process. There can be benefits to both systems, but it's kind of the same spiel we have when it comes to energy efficient appliances. If you have a working natural gas or propane ducted heating system, it's best to keep it and use a ductless mini split to greatly reduce the use of that legacy appliance. However, if the furnace fails, then you may be in an opportunity when you're looking at replacing that unit to consider replacing it with a heat pump furnace. But we certainly don't recommend replacing a working unit. The ductless installation is much easier and more cost effective, and they truly heat and cool very well. The ductless systems also come in a variety of configurations. Some have one indoor unit alone. Some you can put multiple indoor units to a single outdoor unit. And citing this is important, and we'll cover that. Steph will cover that a little bit more in the next section. But you can also get ceiling mount indoor units too, which we have a picture of later in the presentation. And again, you know, we really think, as we'll get into in greater detail today, these ductless mini splits are really going to be a great opportunity for tribal housing, not just because they're energy efficient and work well, but the install is also relatively straightforward, and it presents an opportunity for local workforce development. And if there's some large federal grants that come out that don't support renewable energy development, this feeds into the efficiency. You know, we're going to use less kilowatt hours instead of worrying about adding new generation devices to meet the current usage. Let's save folks money on their bill by reducing their energy consumption. Thanks, Steph. So to summarize this section, let's contrast air source versus ground source. So both types work on the exact same principles, but they use different heat sources. The air source is extracting heat from the air, and the ground source is using the benefit of that stable temperature of the ground 10 feet under to get it either up to 60 degrees if it's cold outside, or down to 60 degrees if it's hot outside. Air source typically is better suited for retrofits on existing homes or buildings. Ground source is much more expensive to install, but you know, they can be a bit more energy efficient in the overall scheme of things, because you're just using electricity basically to circulate the water. That's the largest component of energy consumption. And again, the higher cost for install fit the tribe if you have trenching in-house with, you know, or with a local contractor. But this is typically best suited for prior to new construction, or if there's a large parcel of undeveloped land immediately adjacent to the facility. I say facility instead of house because typically the cost of these systems often eliminate residential applications. Certainly not always, but I would suspect that the only way you're going to do ground source with a house is if you have grant funding to support that, because it'd be very difficult to make that pencil without it. And, you know, really the choice between the two comes down to budget and the situation you're in and your long-term goals. Next slide, please, Steph.
All right, please keep the questions coming in. Again, we'd love to make it as conversational as possible for a webinar. I'm going to jump into just the how to size and locate your heat pumps, and we'll kind of focus on retrofits because that tends to be what folks are doing. But if you all do have a housing authority and you're putting in new homes, it really is ideal to plan these as part of the initial home build, because you can be a little more flexible with location and really be smart about where you're putting those head units in the home to heat and cool it most efficiently. So you can see here in the photo, it says heat pumps come in various sizes and configurations. So there are options, and that's because a lot of these, again, are retrofits. And so there are a lot of different designs available to meet people's different needs, depending on how your home was built. So the first thing you need to do is look at the square footage of the space that you're trying to heat. As Mike was mentioning before, there are systems that have multiple head units. Typically, there will be 2 head units for one outside heat pump. And so if you are looking at a configuration like that, make sure that you're looking at the square footage of the 2 rooms combined when you're sizing the heat pump. So the table here, oh, and I should just back up and say, heat pump capacity is measured in British thermal units, BTUs. Just for fun, because we love using every system to talk about different sizing. But these are typical sizings here that you'll see: 9,000 British thermal units, or 12,000, or 18. And these are the associated square footages. That's what they're rated for. But we do have a note there that says if you use a fan, you may increase your ability to heat a larger space. We've talked to a lot of different folks who, have a heat pump in a bedroom and they use a box fan to blow the heat out of that room and into the rest of the home, and that works really well. Or if you've got a ceiling fan that can help circulate the air, that can be really helpful. So, a lot of folks, if they're retrofitting, they'll pick to put a head unit in the living room first, and that's connected to probably your kitchen and some other open areas. And so if you're able to use a fan to circulate that air through those areas, that'll just help. John, thanks for the question. So climates where this table applies and where it doesn't. This table is typical for anywhere. Again, you can use a fan to circulate the air, so you don't necessarily have to get a bigger unit. But the units in general, we've seen them work well in really cold climates and really warm climates. So this is just kind of, on average, these are the square footages that are applicable for the different size units. But again, if you're using ceiling fans or box fans, that can really help circulate the air so that you can use a smaller unit. And I'll get more into the dual head units as well when we talk about installation. Does that answer your question, John? Hopefully. As I'm reading this other one. Awesome. That's a great comment. Yeah, I've seen the heat pumps work really well, even in big commercial spaces like what you're saying there. Because yes, you can kind of control each area and not severely increase your usage. So that's a great comment.
Yeah, these are meant to be more. And Steph, I hope I'm not taking your thunder in any upcoming slides, but the square footage on those is really rated because the constraint is the indoor fan within the internal unit. And so to be able to maximize that square footage, as Steph mentioned, recently working with the Housing Authority in California, and one of the employees said that she had one in her bedroom and simply put a box fan by the door to circulate the air through the home, and it did a great job of heating and cooling her entire house that way. And so oftentimes the square footage is simply constrained just by the fan capacity of the indoor unit. And yes, you are going to have a little bit of a higher electric cost by operating an additional fan, but it's nothing compared to using a legacy heating and cooling device. It's really very minimal increase in usage to help that air circulate so it can do its job and heat a much bigger area if you choose as well.
And you're not going to see, previously I think you saw a lot bigger price differences in the units. You're not going to see that significant of a price difference between these different sizes. So you really can go bigger if you need to. You know, even that 18,000 is going to be pretty low. We'll get into how to calculate the actual energy usage. But even with the bigger systems, if you get an 18,000 or 21,000, you're still using minimal electricity compared to something like baseboard heating, or, you know, a legacy system that's consuming a lot more, like those traditional air conditioning units. Those really suck a lot of energy. So these are really minimizing your energy usage regardless of the size. So when you're figuring out where to place these, Mike was mentioning earlier, there are kind of two configurations. You can do a wall mount, or you can do a ceiling mount. The ceiling mount typically requires somewhere around a foot of clearance up into the ceiling. So that is a consideration, but they come in different shapes and sizes. So, you know, whether your ceiling joists are 12 inches on center or 24, you can find different configurations that fit into all those different construction types. So they make different shapes and sizes that go into the ceiling. Some are slimmer profiles. So if you do have less room up in your ceiling, you can look for one of those. But one of the times, you know, you might want to use those ceiling mount, you can see the wall behind me is packed with windows. So if I was trying to mount on that wall, I wouldn't be able to, but maybe I would choose a ceiling mount if I were looking at that specific wall. You don't want to mount these directly above a window for a lot of reasons. It's going to get in the way of the condensate line that needs to run down and out to the heat pump. But also it's going to restrict how the air is circulating in the room if you've got it directly above a window. So you really want to avoid that if possible. If you can find an empty wall that's shaded, that's kind of the ideal placement if you're doing the wall mounted unit. But if you don't have that, you know, it is worth looking at those ceiling mount units to get better efficiency there. We do, again, for a retrofit, you know, you're looking at picking an external wall where you can mount your head unit and mount the heat pump on that same wall on the outside. So you need to pick a wall where you've got a location outside to put the heat pump and you've got a place inside to put that head unit. And again, Mike showed a picture previously, but if you can mount that heat pump, the external unit higher up, that can really help with efficiency. But also in places like, you know, my tribe's in Browning, Montana, and there are years when 10 feet of snow hits the ground. So you don't want that snow blocking that heat pump. So if you're able to mount it up higher, you're kind of removing that obstacle from it and making sure that you've got maximum efficiency. But just shortening that line run between that external heat pump and the head unit is really going to give you a lot of efficiency too, because that's where you're going to see any of your losses that are happening. And again, if you're going to use the dual head unit with the one heat pump, you want to pick two rooms that are adjacent and share the same external wall. That tends to be like, you know, the smaller bedrooms in a home. If there are two bedrooms that are side by side, you can get the dual head units and one heat pump on the outside for those. So again, just be strategic about how you're placing those head units so that you can get the heat pump on the outside of that same wall and shorten that line between the two. Any questions there on locations or configurations? So a little bit of math fun. So again, the heat pump capacities come in British thermal units, but you can actually calculate the equivalent in kilowatt hours. And the reason you would want to do that is to calculate your savings. So our energy bills come in kilowatt hours. That's what we're billed in. So it's really helpful to understand, you know, how much these are going to use. So there's just an example here. Every heat pump is going to come with a SEER rating, a seasonal energy efficiency rating. And they all tend to be around 20. You might find 22, you might find 18. They're going to be around 20. And if you take that capacity in British thermal units, so here's kind of one of the smaller capacities, a 9,000 BTU system with a SEER of 20. If you just divide by that SEER rating, that's going to tell you the wattage, the power usage of that unit. And a 450 watt unit, that's the same as 0.45 kilowatt. So it's the same whether we say it's in watts or kilowatts. We've converted to kilowatts because we're building kilowatt hours. So that means that for every hour we use this system, we're going to use 0.45 kilowatts. So if you multiply that by an hour, you've only used 0.45 kilowatt hours, which is really small energy usage. So you see here, if we operated that unit for 8 hours, that would be 3.6 kilowatt hours of usage. And if we were going to assume we're operating that unit 8 hours a day for the whole year, that would be 1,314 kilowatt hours. So if that number is hard to digest, the typical like 2-bedroom home in this country uses 8,000 to 12,000 kilowatt hours per year. So this is probably a high-end 1 month usage for a household. So if you're only using, 1 month's worth of energy for the whole year on that system, that's still a pretty low number. And if you look at your energy bill now with that, so let's say you pay 10 cents per kilowatt hour, you're going to multiply this number by 0.1, and that's going to give you that total price, which would be about $131 per year to operate. So if I was operating this for 8 hours a day, the whole year, and paying 10 cents a kilowatt hour, I'd only be paying $131 for the whole year to operate this thing. So again, these are really efficient, really low cost to operate. If you want to go in and do a 24-hour operation, you can do that too. I think in a lot of places, especially around shoulder seasons, you're either not going to be on or not using a lot of energy because you're already going to be in a comfortable temperature zone. So that really minimizes those extremes. Give an example of inefficient ones. So if you have an older unit, again, you need to figure out what the SEER rating on it is, what that energy efficiency rating is. And you should be able to Google that for a unit, or if you can't, you can contact the manufacturer. But let's say, for example, it was 10 instead of 20. That's really an extreme number. But if I divided by 10 instead, then this would be using 900 watts instead of 450. And so I would then take that 900 watts, turn it to 0.9 and multiply it by the 8 hours. So it's basically going to double the usage. So instead of coming out here with the 13, 14 kilowatt hours, it would be 2,600 kilowatt hours. So again, still a super relatively low number in terms of energy usage, if you ask me.
And there's there's something else too that I apologize we don't have in the slides, but there's a coefficient of performance number, a COP number with these. And basically most of them on average are around 2 to 3. Most are getting to 3+. And what that means is it's basically a measure of the efficiency. It uses one source of electricity. It can output 3 of heat. And they make some of these now. And I know some of the national labs are really researching extremely high COP values, but the price goes up exponentially with that too. And so, we really recommend a COP of 3 is great. You're getting 3 units for the price of 1. And really where these things, it's a combination of all things. So modern air conditioners, ducted air conditioners typically have a very similar, but where these things make up in efficiency is, you know, they have the same refrigerant in them in the newer models. But that's where the ductless moves ahead, because the ducting system in of itself is kind of a sink. You know, by that I mean you lose a lot of the thermal actually going ducting, and so they're not as efficient. It's great to have whole house heating and cooling, but again, being able to put in a heat pump and have a fan to help that air, or ceiling fans going to help the air, you're still way ahead of the game when it comes to the energy consumed, because the air conditioners have to run significantly longer to get the house to the temperature set on the thermostat, because the ductwork itself is so lossy, particularly in larger homes where the ductwork is bigger. And then you have the benefit of that reversing valve where the heat pump can heat as well as cool. And so it's a combination of multiple things that make these really ultra efficient and cost saving for people. And, you know, we've talked to people all across the country that have had them for several years, and it's really low maintenance. You know, we have people that have installed these that haven't been happy with the performance, and you have to get in and tinker with it all the time. It's not the case. It's kind of an install it and forget it. You know, we'll get into later in operation and maintenance. You know, there's components of the homeowner needs to be educated on this device as well to maximize savings. And there is some routine maintenance and more, you know, other maintenance that pops up every year, that's a little bit beyond the abilities to keep it operating in peak performance. So there is still work, contractors or workforce to be able to be in these units on occasion. But for the most part, this isn't a, you know, a flawed appliance. This isn't something that people are really unhappy with. By and large, from Alaska, California to New York and Minnesota and Florida, all over the place, people are having deployment of this appliance with great success.
Yeah. And I think, you know, what I've seen in some cases here in Washington State is, you know, when people are doing the retrofits, maybe they'll put one head unit in the primary bedroom and one in the living room, and then still do, you know, space heaters in the smaller bedrooms and things like that. So you can still couple this with other, you know, heating and cooling measures as well. And you're still going to see, again, that efficiency if you're using it on some of your bigger rooms in the home. But again, if you're able to use fans to circulate the air, in some of those cases, I know folks just kind of close the bedroom doors of the smaller bedrooms so that, you know, they're heating the spaces that are used more and not so much the ones that aren't. But that's very situational, you know, depending how the home's being used. But I appreciate that comment, John, about some of the older units being 12 to 14. So again, you can go in there and do that same math, you know, using 12 or 14, but you're going to see that it's not even quite double what that energy usage we calculated was. So it's still going to be minimal compared to some of the other heating and cooling that you might see. All right. Keep the questions coming in. So this is just looking through a utility bill to see what your current usage is. So this is an example of a home. You can see here the summer months. This turquoise is your heating and cooling. So this is kind of the cooling, which is probably just fan usage because it's not very high. And then this is heating here. But below that, you see the usage for each month. So the way that we calculated the base load, and the base load is just everything that's not heating and cooling. So it's that little rectangle on the bottom there. You take your 3 lowest months from 12 months of usage, and you're going to add them together and divide by 3 and multiply that number by 12. And that's all written here, so you can kind of walk through it with the calculator. So if you gather 12 months of your bills, you can do this exercise to figure out what is your base load and what is your heating and cooling load. And that really helps you figure out what your current usage is so that you can compare it to, okay, what if I put in a heat pump now for my heating and cooling, what is that going to use? You can kind of calculate what those savings would look like. I live in a state where I think just about everybody's all electric. Some folks are on propane and electric, but a lot of our state has gone full electric. And so incorporating the heat pumps tends to just, be a really good efficiency measure, especially if you've got the legacy baseboards, which a lot of the older apartment units and things in this state have. So putting in that heat pump is really going to save a lot of energy. But again, going into your base load, so we added our 3 months and divided by 3, multiplied by 12. That again gave us this rectangle down here, the orange rectangle. So that's everything in the home other than the heating and cooling, every appliance, every lighting fixture, that's what that's using. And then the seasonal load, to get that, we're going to take all of our usage for the 12 months, add it together, and then subtract that base load. That's going to tell us what's left for this heating here in the winter months and the cooling there in the summer months. So that's going to tell us our existing seasonal load that we're using for heating and cooling. And that'll be a great comparison. Again, if you're doing the calculation of what would a heat pump use, you can see what those savings would be. The energy index calculation is a way to kind of compare homes without square footage. So if you've got a 5,000 square foot home or a 1,000 square foot home, we're actually dividing our kilowatt hour usage by our square footage. And so that's going to tell us a number where we can compare efficiency of homes without worrying about what the square footage is. So I could compare a really big home to a really small home and see which one's using more kilowatt hours per square foot every year. So that's a really good number to calculate, just to kind of compare home to home and see, if you know that you've got a really leaky home and somebody else has one that's sealed up really well, you can compare the two and see that difference. Effective cost per kilowatt hour is a calculation you can do just to see what are you actually paying per kilowatt hour. That includes all of your fees and other things. So maybe your utility tells you you're paying 12 cents per kilowatt hour, but then they're charging you some other fees and taxes and things on top of that. It's kind of just upping that number to what are you really paying per kilowatt hour. And that's an important number to understand, because if you're trying to calculate these savings and you know what you're paying per kilowatt hour, you can really effectively calculate, how much am I going to save each year if I put in one of these units, for example. And then at the bottom here, this is kind of if you were, and we'll talk about this more in a minute, but if you were in a state that was, had good net metering policies for solar, what system size would you need to offset your usage? So where I live in Washington State, the rule of thumb is basically if you use 10,000 kilowatt hours per year, you would want a 10 kW system. If you use 20,000 kilowatt hours per year, you would want a 20 kW system. And that's going to give you roughly the correct size of solar array that would give you the energy usage that you're using in a year. If you go farther south, you can go with a slightly smaller system. You're going to get a little bit more efficiency out of the panels. But it's just a good rule of thumb to understand what would cover your usage. Questions there on any of the calculations? People who don't love math as much as me.
One thing I want to mention, Steph, is so for the base load, the orange rectangle, that's going to largely be behavioral. So there's behavioral habits, and that comes with homeowner education. It seems most utilities are starting to move to a time of use rate. So between like 4 and 7 in the afternoon, they might be a peak rate to charge. And it's educating the homeowners to maybe not do the load of laundry between 4 p.m., maybe not run a load of dishes between 4 and 7 p.m. In those types of behavioral modifications is how we can decrease that number. But the one appliance that really can make an impact too is they also make air source water heaters, water heaters that are incredibly efficient. And so the water heater is an appliance that's consuming a lot of electricity 24/7 typically, and adds to that box. And we're not going to spend a lot of time talking about that today. In fact, other than this point, we're not going to talk about it at all. So I wanted to mention it for awareness. And also, these systems, these pair really well with rooftop solar. First we would want to go in and make sure that the house is air sealed and there's proper insulation, and so it's weatherized and sealed up, and then look to really pair a rooftop solar unit with these heat pumps, particularly if you're in the southern part of the country, to maximize the cooling load when the summer solar energy is going to be producing at its highest. Depending on where you are up north, the net metering policies, and I know we're going to get into that a little bit more later, but it can be a little bit more difficult to offset that winter heating with summer solar energy. But even without the solar, members are going to be well ahead on their bills. But it does pair really well with solar. We're just also kind of catering to the federal landscape and their lack of ability to seemingly to develop community and residential scale solar projects. That doesn't mean there's other resources out there. And that's something that on a case-by-case basis, as we assess this, we're always looking to help offset any additional use. And this graph in particular is from Eastern Washington, and they never had a lot of cooling in their homes. It's just all electric heat. And, they never really needed cooling. Well, it's getting really freaking hot there in the summertime now, and they are very much interested in cooling. And so how can we pair with some sort of solar, because the energy bill is going to go up in the summertime by running these appliances when they're not replacing a legacy unit. And so we need to be considerate of that. Some people may choose to operate the appliance and have a higher energy bill just for the comfort added for being in your home. The home you spend most of our time, and we want to make sure that membership's comfortable in their homes. But I'm belaboring this too. But we typically look to try and pair these appliances, because they run on electricity, tend to pair really well with residential solar projects.
Awesome. Thanks, Mike. So if you're in a place where you use gas for heating instead of electric, you can do that same analysis that we just did, except your gas usage is measured in therms. Yet another different way to measure your usage. A therm is about 100,000 British thermal units. So that's what therms are, but that's what your gas usage is going to be measured in. So if you do those same calculations that we did in the last slide using your therms, you can literally Google, let's say you use 5 therms. You can say 5 therms to kilowatt hours, and it will do that calculation for you to tell you what that equivalent kilowatt hour usage is. But that's a way you can try to kind of compare apples to apples and say, well, currently my heating is using this many kilowatt hours. This is what I would use with electricity. But there's a caveat with that, right? That gas tends to be a lot cheaper per therm than energy is per kilowatt hour. So even though you might be 1-to-1 more efficient using an electric mini split, it might still cost you more depending on where you live, right? If you're in California where you're paying 61 cents a kilowatt hour, and maybe you're paying 5 cents a therm, just making up a number, but you still might be doing better cost wise with that gas heating than you'd be doing with electric heating. So you're still going to have to kind of run the math for where you live, but this is just a good way to compare the efficiency and say, I can compare what I'm using in gas to what I would be using electrically in kilowatt hours with a heat pump. And again, the note there, if your local net metering policies favor it, you can consider a solar installation to help offset the cost. That's going to vary state to state. Every state has a different net metering policy, and the way the utilities adopt that is also varying even within the state. So It's something to look into, but again, in some cases, it's not necessarily going to pencil out to add that solar installation. But if you're in a place where it does, that can really help offset the cost of adding the heat pump. So in places where it's doable, you know, we recommend putting in the heat pumps and putting in rooftop solar. Again, that can help offset everything. Questions? We'll let Mike jump into the installation.
Thanks, Steph. Please, again, as questions come up, put them in the chat. We'll get into a little bit more of heat pump installation and retrofits from air source heat pumps and, you know, ducted and ductless. The picture on this slide shows one of the ceiling cassettes that we were talking about that can be used with a ductless mini split versus the indoor head unit that's typically mounted high on a wall. I think these are typically used in drop ceiling scenario where you can't see the exposed device mounted to the roof. And there's a reason for that too. You know, we've got a couple of examples that I kind of scratched my head at because in this case, they have to run, it looks like the lines are running a bit horizontal into where it's finished. But typically we want to make sure that the condensate line is able to gravity flow out of the home. And so air carries moisture in it. And so these units do need to relieve that moisture to the exterior of the home. It's nothing significant, but the water does need to be able to get off of the device and out. And so that's something that we consider how and where we mount these. Anyways, the ceiling cassettes operate off of a remote control. Most of the wall units have a remote control as well, and also the ability to manually control on the unit itself. But I think that's it on the slide. Next slide, please, Steph. So remember, there are two main types of air source heat pumps. We've got ducted systems to replace a legacy ducted furnace, as well as the ductless mini splits. We'll get into the ducted retrofit first. As you can see by the graphic on this slide, the ducted systems, they often have a larger outdoor unit and consume more power than the ductless, moving air throughout the entire home. And again, the ductwork itself transfers heat or cool, you know, it's a thermal highway basically, and makes them less efficient than the ductless models. And so if you notice the arrows on the outdoor unit, the air intake is on the side of the unit and it blows the return air out of the front of the unit. And so when we're mounting these, we want to be considerate of mounting them in locations. Those are free to be able to flow air. And same as Steph mentioned, you know, one of the other reasons why we don't want to put a head unit over a window is we don't want any curtains or anything obstructing that head unit. So we want it kind of on its own space on the wall, plenty of room to be able to, you know, both expel the conditioned air and suck in the return air. Next slide, please, Steph. So here we've got a picture of a natural gas furnace retrofitted with an heat pump. This particular heat pump is vertically oriented, meaning that it draws the air from underneath and moves it straight up, drawing the return air from the side and up. And so because it's that way, as you can see in the picture, they had to rework the ducting to build out underneath of the heat pump, and also along the side, they had to widen the duct because the air is actually having to make a 180-degree turn. It's going down and it has to turn once and then turn back up into the furnace. I'm not going to spend a lot of time talking about this. You know, we're not going to get into great details of things. But we have to make sure that that's wide enough because air is not that different from water or any sort of fluid where friction account for the friction. And we want to make sure that there's adequate space to be able to pull the correct amount of air. The air goes in, air goes out, the same amount of air. And so we need to make sure that the return is big enough to get enough return air to the home. without decreasing the airflow. And so in this particular case, the original furnace was a higher efficiency unit, and we can tell by the two PVC pipes coming off of the furnace on the left. That's the legacy natural gas furnace. And so those higher efficiency units, which some of you may have in some of your tribal housing, it draws air entirely from the exterior of the home, both in and out, and circulates that air into the combustion chamber. And so this ensures that the gas doesn't mix with the air circulating in the home and minimizes issues with carbon dioxide or carbon monoxide and radon, amongst other gases. So in my case, my house was built in 1996. I have a pretty old furnace that actually draws air into the front of the furnace from my basement. And I'm in the Colorado area, and we have a lot of issues with radon. I had when I first moved in, a crawl space that didn't have a vapor barrier or anything on it, and it's pulling all of that air from my basement, and that's what it's heating and circulating through my home. And so there's great benefit to having these higher efficient units. But in this case, that's something else that had to be handled during the retrofit. They had to be sealed off on the exterior of the house. The gas line had to be capped off. As you can see in the picture, the ducting was also reworked above the unit, as the new unit is taller than the previous. And we can't see in the picture, but a new electric line and breaker was certainly run by an electrician as well. This unit operates on electricity and probably needs a 50 amp breaker and 220 volts run, where the previous one was, there's some electric components, fossil fuel furnaces as well, but it probably just had 110 volts and a 15 or 20 amp breaker. And so all of these costs with these retrofits go into the overall cost, plus the cost for the unit. And again, there still had to be an outdoor unit, had to be secured and installed, and the refrigerant lines run and charged as well. And so that's a lot of cost. That's a lot of work and expense that you may or may not have locally to help support the retrofit of a ducted system. Next slide, please, Steph. Any questions on that?
A couple.
Not if the house was, so you're talking about the exterior unit. I think that the exterior unit, we want to probably try to avoid the south side if we can, so it's not in direct sunlight. We'll get into that a little bit later. I think that the biggest area for efficiency loss, we want to really minimize the length of refrigerant line, the line that's run on the exterior of the house. And, those lines are insulated, and then they're also, on top of being insulated, they're mounted within usually like a plastic conduit. But environmental factors still impact, super cold temperatures or super hot temperatures are still going to impact that refrigerant line. And that's really the vulnerable piece. So we want to keep those to a minimum. I don't think wind is really going to impact its draw or expel the power. The fans should discuss that. It would be a matter of making sure that it's high enough for the snow, so the snow's not drifting, so the wind's not blowing snow drifts against it, would be something that we'd look at. And again, you could still mount it on the south side of a home if that's the desired location. It is going to probably have a bit more of an impact. It's going to be very, very minimal, but that is something to consider with the sunlight directly on the unit. But we would also want to make sure that the house was sealed properly, right? We want to make sure that, that particularly on the prevailing wind side, but, if you had a chance to attend our energy audit training, we use a blower door to basically create a situation where there's a 20-mile-an-hour wind blowing on all of the walls externally simultaneously to be able to identify leaks. And we would definitely want to ensure that the home was properly sealed and insulated before installing one of these. Next slide, please, Steph.
I was gonna, Pamela had a question about installing a fence around the unit.
Oh, yeah.
I don't know if you want to
go for it.
Okay. I'm curious what the purpose would be, but you could definitely install a fence around the unit as long as you're not obstructing the airflow in and out. So depending on the purpose of that, I would say definitely keep it, enough away from the unit that you're not obstructing the airflow. But I don't know if that was for critters or what.
It potentially could be snow, and you would have to have some sort of ventilation, similar if you've ever seen like storage closets that have your water heater and furnace in it. Oftentimes there'll be a vent on a door if it's in a small closet, just to ensure that enough of the outside air can get in for it to operate properly. You would have to have a similar kind of configuration. I think depending on the size, you might want to make it a bit oversized and it'd probably be okay. I have seen people that put a kind of an awning over the top of them as well. The ideal situation, I think, would be mounting it under the eave of the house, pretty well up high. It's for the amount of maintenance that's required. It's a lot easier to have the maintenance technician use a ladder for the rare occurrences where the cover's off and they're doing maintenance to keep it operating in a good spot. And oftentimes it's just a couple of brackets on the side of the house to get it mounted up high. But that's a great question. And I think anything could be possible. We'll get into a bit later with the homeowner education, and part of the maintenance that the homeowner should be conducting, particularly in cold climates where it's snowing, is to where they can actually see the unit and get out and see it and make sure that the defrost cycles, these have internal defrost cycles to help minimize ice buildup from and the exhaust, and to make sure that there isn't any ice buildup preventing airflow either going in or coming out. Does that answer your question? If not, please just, okay, thank you. So now we'll discuss ductless mini splits, which are far easier and much more straightforward installation. This is the same graphic we had earlier. As you can see on the graphic, we have the outdoor unit that needs to be mounted. We would probably recommend getting it off the ground, depending on where you are in the country. And also, we would look to probably mount it somewhere against the wall where the indoor unit head is mounted as well, because again, that refrigerant line run is really our most vulnerable space for efficiency. And so we want to try and keep that to a minimum. It's going to have, this isn't something that's going to have a devastating impact on the performance of the unit, but that's really our vulnerable point. And so we want to try and keep that to a minimum. It's a lot easier to have a longer run electric line. There's absolutely no impact on that by the outdoor environment. So if we can get the outdoor unit mounted in close proximity to the indoor head unit, that's the best case scenario. We have to make sure that both the intake and the exhaust fans are clear. It looks like this one, the intake is mounted right next to this bush, and probably not the best place to mount it for airflow going in. And also, since that's the intake, depending on where in the country, if that bush sheds its leaves or anything, it's going to be going right into your intake fan and blocking it. And so, those are things that we're looking at. And again, as you can see, the lines are insulated and then housed in that plastic conduit, but external temps still play a role. We want to make sure we have that as close to the unit as possible. It gets a bit more difficult when we have lines running to multiple indoor units. It's hard to minimize the length of the run for the refrigerant lines. But in that case, we just try to ensure the outdoor units kind of located between the two. And we want to try to keep multiple units on the same exterior wall because of this. Next slide, please, Steph. And so that brings us to the mounting of the indoor unit. So this case has the head unit, and it's running all of the refrigerant, power, and condensate lines up to the attic. We would try to avoid this, as the condensate line, again, should be able to flow naturally by gravity and not have to be pumped up to get out of the house. But typically, this involves about a 4-inch or so hole being cut into the wall and a mounting bracket to hang the unit on, and running all of the refrigerant lines, the wiring. There's a power wire, signal wire, and condensate line out the back of the unit. So there's no conduit exposed in the house for a really clean finish. And again, we want to make sure that we're trying to put it in a situation where that condensate line can drain to the exterior. We don't want the unit filling up with water and not being able to push that condensate out. And so, you know, when we're installing this appliance, you'll still need an electrician to run power and a new breaker to the external unit. And there's also, we haven't talked much yet today on, but there's different versions of these units. There's some that come pre-charged where you don't have to worry about the refrigerant. And so the unit can come pre-charged, or it may need to be charged with refrigerant. The benefit of the pre-charged units is you don't have to mess with the refrigerant. They're ready to go out of the box. The negative component of that is you lose the ability to change the length of the refrigerant lines. In order to charge the units, you have to have an EPA 608 Type 2 certification for high pressure HVAC, and Steph is going to discuss that in greater detail in the next section. Next slide, please, Steph. So as we mentioned previously, both types require an outdoor unit, with ducted systems typically being much larger, often the size of 2 of these in the picture, one on top of the other. The picture shows a unit mounted off the ground to minimize drifting, and they ran the refrigerant line to the, if you see the white conduit box. We would prefer to run it straight up or even behind the unit straight into the wall to minimize that exterior environmental impact of the refrigerant. I know I'm kind of kicking that dead horse, but that truly is the big consideration for efficiency. And, you know, again, we'd prefer to have a longer electric run. Outside environmental conditions have no impact whatsoever on the electricity run into the unit. And so, you know, keeping that refrigerant line run as short as possible, it really doesn't matter how close it is to the breaker box or power. Next slide, please, Steph. And then, so Steph's going to get into workforce development. But before we get into that, I just wanted to highlight the picture on this slide as an example of what we're kind of talking about and looking for. Running behind the, it's a nice, clean appliance for the homeowner and no conduit running on the wall. So I think that many of these are warranted for like 15 or 20 years. It's really long life, and really the life of the ground source heat pumps are even longer. You know, I think the cost of these units, the ductless mini splits, are typically, they vary greatly in price. You know, but I think you can get a pretty reliable good one for $2,000 or so, less the cost of installing it. And the ground source, again, it's hard to give an estimate because it really depends on the size of the facility and the terrain needed to trench that piece out. But those ground should be good for like 50 or 60 years. They're incredibly long life. You just might have to do some maintenance or replacement of the pump. But I think that these units, as we've talked about before, people have really had positive feedback in terms of the maintenance and them breaking down. I would suspect that by the time it has reached the end of its useful life, there's not a lot of repairing that would be going on. The units will probably be even cheaper at that point, potentially, to just replace them. But I think that these are probably good for well beyond what like a legacy heating and cooling, you know, 15 or 20 years. Great questions. Thank you.
Yeah, just as a quick example of that, my parents built their house. It's just about 20 years ago, and it was 1 or 2 years after they built their house that they retrofitted with 2 mini splits, one downstairs, one upstairs. They literally just had them maintained for the first time, and they've been in there for 20 years running with zero maintenance, which is not recommended, but I will hop into the maintenance in a minute. But that's just, one example to show you those things can be installed and just run, but there is some maintenance you do want to do to keep the air cleaner. So I will jump into that here. Workforce opportunities. So again, just with the installations, this is a great workforce opportunity. Again, if you do, choose to do some ground source, especially with maybe like your administration buildings or health clinics or things like that. I've seen that done here in the Pacific Northwest paired with solar, and it works really great. If you've got folks on site that can do that excavation, that's a great employment opportunity. But installing them, whether it's residential or commercial, that's a great opportunity as well. If folks are not EPA certified, which again, I'll talk about that in a minute, but you could start with the pre-charged units and get people a little bit of experience, just doing those basic installations, and then have them take the test to be able to get the ones that need the EPA 608 certification for the charging of the lines. But this is a great opportunity, especially if you've got folks who are already working for your housing authority or already local contractors to do additional work that, it's not going to take an extra skill. If you know how to do basic construction, you're going to be able to install these things. And again, once you get that 608 certification, you can charge the lines as well. So if you've got local electricians, local plumbers, this is really a great way to just expand people's abilities and provide local workforce. With some of the commercial scale buildings here, I'll say, a tribe that I worked with actually had to hire somebody from 3 states away just to come in and do a ground source heat pump installation on an administration building. And so it really is an opportunity for folks, if they're able to do this work, to keep that money local within your tribe. So we are working on putting together a test prep curriculum for the 608 cert. But this is something folks can take online. And so you can, study for the test, and then it does have to be proctored. You can't use a smart calculator. You have to use the basic calculator. So there's some math that has to be done on this test, but they provide kind of the charts that you need, and, you can do the math with a basic calculator. But we are working on some curriculum, but currently online, you can find different folks that have online curriculum that you can use. And there are test books too that you can use to study for the test. So once people get that certification, then they can do charging of the lines themselves. So I'm going to talk through a little bit of operation and maintenance here. So the first thing here is there are no prerequisites, William. You can take that test, and you can take it as many times as you need to pass it. I've heard some folks take it a few times depending on the the test prep. There are some better test preps and some less good test preps, but yeah, you can take it and retake it online. There is obviously a fee for that, but maybe Taro can cover that in some cases. That's a great question. So in terms of operation, these systems are really efficient if you set them to a level and leave it. Now, that said, a 2-degree adjustment is not going to cause anything major in the system. And so if you're leaving the house during the day and you want to lower the temp a couple degrees, you will see some savings in that. But like a 10-degree swing is actually going to stress your system if it's trying to heat 10 degrees, once you've had it off that's going to take a little bit more strain on the system. And so it's really helpful if you can kind of pick a setting and leave it at that setting. And again, if you're gone during the day, have it go down a couple degrees. That'll save you some money, but don't be lowering it 10 degrees during the day, because then when you come back, your system's going to be stressed trying to catch up that 10 degrees. They operate a lot more efficiency if they're just kind of holding a pretty steady temperature. If you've got a retrofit, you know, the homeowners are going to need some education to make sure that they're operating everything appropriately. If you've got legacy baseboards and you add a mini split, but you've got the baseboards turning on before the mini split does, that's not really helping your cause. And so the homeowners will need a little bit of education to make sure that they're using the current setup the most efficiently possible and minimizing that energy usage. Again, we've mentioned the fans a few times. So the mini splits do have built-in fans, and depending what model you get, I've got a model that has dual fans. So one is kind of doing the up and down and the other's doing side to side with the air. So it does a pretty good job circulating the air, but you'll see differences in some of the head units. So maybe you only have the up and down fan, and, you know, having a ceiling fan or a box fan running regardless is probably going to help circulate that air in the home. So again, even if you've got kind of a smaller system, I think you can very effectively heat or cool a small space just using those fans. And then behaviorally, you know, so that you can set it to a level and leave it. You know, if people need to get blankets or, you know, wear a jacket or a hoodie around the house, you know, just to make sure you're keeping that system set to a constant temperature. You don't want it to be one of those cases where you've got a cold day and now somebody's cranking it up to 78 because they're feeling chilled. It's better to make those behavioral changes and keep it set to a pretty consistent temperature, and find other ways, you know, to keep yourselves comfortable. So if it means moving a chair closer to the fan or something like that, you know, making some behavioral changes, I think in general, in home usage, you know, will really minimize people's energy usage and save folks money. Questions on that piece? All right.
And again, sorry, Steph, just to be clear, I mean, these units are more than capable of running at 78. We just have those conversations with folks in terms of trying to maximize the energy savings. And sometimes there is a component to using blankets or things of that nature, and just making sure they're aware of the trade-offs. And they may want to crank it to 80. It'll heat to 80 just fine. They're just going to be spending money for it. And we definitely want people to be comfortable in their homes. We don't want them running this thing at 60 or whatever, you know. So there's a fine line there, but this isn't like a solar project where we can install it for somebody and it does all the work and they don't have to think about it. There is some user interface to help maximize the savings of this device, and that's what we need to spend time with them on and make sure they're informed on how to properly use the system to you know, make those savings as great as possible if that's their goal.
Right. So into the maintenance that folks were asking about, again, it's pretty straightforward. The most routine thing you can do, every head unit is going to come, I'd say 99.999% of them come with a reusable mesh filter. I've got mine right here to show you what it looks like. So this just sits at the top of the head unit, and it's got, you can't even really see it, but these are mesh filters in here. So as the air is coming into the unit, it's going to trap those particulate on top of this mesh filter. You will need a ladder because your head unit's going to be mounted up high to get this off, but it just has a few tabs that connect it to the head unit. And it's really easy to remove. And all you're going to do is flip it over and spray it either with a hose, or if your kitchen sink has kind of the spray mode, you just want to spray it so that from the inside out, it's getting all of that particulate off that came in as the air was coming in. So that's going to be your main piece of maintenance with these. You do want to, I think the recommendation is every 1 to 2 years to have the units inspected. Again, as I mentioned, my parents just went 20 years and finally got their coils cleaned. But inside the head unit, there are coils that can get some debris buildup or in some cases mold buildup. Now, the newer units tend to have a dry mode that helps kind of prevent mold formation in general in the home. And so if they're being run in that mode, hopefully you're minimizing any buildup. But it is good to get those coils inspected. If you're able to get up on a ladder, you can kind of look at the coils and see if they're getting any buildup. There are kits you can order online to clean that buildup yourself, or you can bring in someone. So that's just another great workforce opportunity. Again, if you've got housing folks or local contractors who know how to come in and clean those coils for folks, just getting those cleaned regularly is just going to help operate the unit more efficiently. So it is good to do. I'd say at least every 5 years or so, have somebody come in and do it, or get the kit and do it yourself. But again, it's pretty minimal. You can definitely install these and let them go. But it is worth, inspecting them and making sure that everything looks good every year or so, just in case it does need to be cleaned. Right. So just some useful resources for you all. Again, we've mentioned the Office of Indian Energy that we used to work for. Their grants tend to come out in the spring. Obviously, the budget needs to get passed before this comes out, but we do expect their next opportunity to come out this spring. They've got both planning and deployment grants. So if you wanted to apply for a planning grant just to do kind of a feasibility study on installing these in some homes and saving some money, you could do that. If you've done that analysis and you're ready for deployment, you can apply for that. And I think typically, if you apply for a planning grant, it should be relatively easy to get a follow-on deployment for that same work. So that's worth looking into. And then the office also has free technical assistance. It's kind of a pre-feasibility technical assistance, so it does have some limitations. But if you've got a project you're interested in, you can definitely apply for that technical assistance. It's really just sending an email to the office and saying, I want help with this project. And then they can get you some resources up to 40 hours. And then there are also newsletters coming out of that office. So there's a link there for the newsletter sign up. They don't really spam you. They don't do regular, too frequent of newsletters, but at least, they'll let you know when the funding opportunities are out or anything that seems relevant. And then the Bureau of Indian Affairs, DEMD, also has a couple of different grants available that you can use for pre-feasibility as well, whether you're doing these kinds of projects or looking at forming a utility. I'm reading the chat here.
Jennifer, I'm wondering if it's the inside or the outside. I'm assuming you mean the inside head unit, but not sure. But, I think that anything that you do to, you can certainly hide it if you want. It's going to make it more difficult to maintain the filter probably, unless you have access to get to it. Anything that you put in front of it to block is going to impact its ability to circulate the air. And so I think it's perfectly fine to have something on top of it and even potentially on the side of it. I don't know that I would recommend something in front of it, but it's just going to cost you more energy to help circulate the air. And potentially if you get fans going, it could still be fine. But anything that you put in front of it is going to definitely obstruct its ability to get the air across.
If I were worried that much about the aesthetics of it, I would look at one of those ceiling units, because those can be flush with the ceiling and not so obstructive looking. So if you're worried about the aesthetics of it, I would look at the ceiling mount units instead, because then you're not going to obstruct your airflow with something. The head units are not small, so blocking them is kind of.
And the only real issue with the ceiling component, as we talked about earlier, It's just making sure that there's a run if it's got attic access or something where we can get that condensate line down, particularly, you know, dry mode. Well, that just means that internal to the appliance, there's a dehumidifier, which means it's going to be running even more condensate to the outside because it's extracting that moisture from the air. So we would need to make sure that it's able to flow easily to the outside, and then it'd be no problem.
Question. The last on the resources, so Tribal Energy Alternatives has a capacity building grant. So if you're interested in any education, training, and workforce, that's a great grant for that. They've also got some deployment grants for both tribal facilities and residential. They've got some gap funding if you've got a grant that requires a match, and they've also got some planning grants. And then Native Learning Center, again, super grateful for the webinar series. They also provide technical assistance. So if you all are interested in any of the on-site training that we provide, Native Learning Center cannot fund equipment, but can definitely help fund the travel and the training. So you can send them those requests and they'll be evaluated on a case-by-case, but really appreciate their support of that as well. And sorry, we've gone a minute over, but if there are questions, keep bringing them in the chat. And I think Brooke will do the outro here too.
I think, you know, to answer your question on the list, if you want, you can send us an email and we'd be happy. I can check in with the folks above the Arctic, which one they're using for their 850. I don't think that there's a lot of lemons out there. My recommendation would be, particularly if you're going for a grant and trying to do any sort of scale on these, whichever manufacturer works with you to be able to buy them in bulk. I don't know that there's a lot of, I certainly haven't heard a lot of feedback from a certain brand that's kind of a lemon. I think these all have very similar internal working. They're all using the same refrigerant. And it would be just up to kind of price point and who might be willing to work with you to be able to buy some sort of a bulk discount.
And the other thing is, if you're doing, you know, pre-charged units, they're going to be very specific brands that offer the pre-charged units. So you just have to Google pre-charged mini splits to see what's available. I don't know about issues with Mitsubishi. I personally have a Samsung and I only got it because it's the quietest one I could find when I got it. So
I'd be curious to know more about that if you have time later this afternoon or this week. If it's more like a ice up issue or what sort of issues you're specifically having with those, so we can pass it on to the other folks we work with.
I'll do the outro real quick. Feel free to keep sending your questions for Mike and Stephanie in the chat. Thank you so much for another incredible presentation, y'all. We can definitely show them some love on the webinar feedback survey. I did put a link into the chat and I'll do it once again. But if y'all have a minute or three and you could complete the webinar feedback survey, it takes about literally 3 minutes total and just helps us know what is working well and what we can improve upon for the future. And we do share that feedback with Mike and Stephanie also. So it helps everybody all around. We hope you can join us for our next webinar. That is going to be this Thursday on the 22nd. This one's going to be Switchgrass for Energy Independence with Roger Kushwa, who's CEO of CRC Biofuel Solutions of America. Same time, same place as today. You can check out this as well as our other recorded webinars on our YouTube channel. There is a full playlist called the Cathedra Webinar Archive. YouTube is a free resource, so I encourage you to check out all the different recorded webinars we have on there. Feel free to also check out our upcoming training events. We post about them on our various social media. We're on Facebook, Instagram, LinkedIn, and Twitter. If you are a podcast fan, we do have a in-house produced podcast called the Hope a Thing, a Native American podcast. You can listen to that wherever you listen to your podcasts. Or if you enjoy watching people's interviews with their special guests, we do post those on our YouTube channel. And to get more of Mike and Stephanie, if any of you are available next week for the Seminole Tribe of Florida 8th Annual Renewable Energy and Sustainability Conference, Mike and Stephanie will be presenting on Monday. All right, y'all, but that is all we have for you today. I did put a link to our information page on our website about the conference. It is free for you to attend. But that is all we have for you today. I hope you have a wonderful rest of your week and a lovely weekend. This is being recorded, so if you want to share that with any of your colleagues, it will be posted tomorrow morning. Otherwise, have a fantastic rest of your day, everybody. Appreciate your time. And Mike and Stephanie, we'll talk soon.
Sounds good. Thanks all. Take care.
Thanks, everybody. Appreciate everyone's time. Sorry for going over, but appreciate your time today.